In this video, we're going to use our understanding of stationary points to find the unknowns in a polynomial equation. So looking at this one, we've got the curve with the equation y equals x cubed plus ax squared plus bx plus c passes through 0, 5 and has a stationary point at 2, 7. Find a, b, and c. Alright, so what you might say immediately is that you've got an equation. The equation has 3 unknowns and you're only given 2 points. So instantly imagine, so this, what I'm drawing now isn't the function at hand we're dealing with, but imagine that my Cartesian axis is perfectly vertical and horizontal, and we've got a cubic function, so we're going to see it cut through the x-axis 3 times. And what it's telling us is, say, it's the function here touches the points 0, 5. So we say we're given a point here and a point here. Pretty much what it's saying is find a, b, and c. And we might immediately think, well, we can't do that. But the reality is we can do it. And the way in which we can do it is I'll show you right now. So what we've got is y equals x cubed plus ax squared plus bx plus c. And this equation here has the following points. It lies with 2, 7, and it also has 0 and 5. Alright, awesome. Now, if these points lie on this equation, and one of them it has 0.27 is a stationary point, what we can infer is that if we take the derivative dy over dx, that's 3x squared plus 2ax plus b. What we can infer is, because we've got a stationary point there, the stationary point, it's going to become 2, 0. So what we've been able to do is we've got an equation with 2 points and then another equation with 1 point, of which we have 3 unknowns, and therefore we can build 3 equations. So piecing all of this together, what we find is that let's do these guys here in a different color. Let's change it to purple. That's better. Purple. Alright, cool. So building our equations, we're going to get y equals x. Sorry, not that. We're going to get 7 equals 2 cubed plus a times 2 squared plus b, 2b plus c. This will become 8 plus 4a plus 2b plus 2c, or plus c. Then this will become minus 1 equals 4a plus 2b plus c. So this is equation 1. Now let's go for equation 2, and I'll leave a little bit of space and you'll see why in a moment. We're going to go not 0, but rather 5 equals 0 cubed plus a 0 squared plus b 0 plus c. All of these cancel, and therefore we find that 5 equals c, but rather c equals 5. So going back to equation 1, we're going to get minus 1, 4, that should be an a, 4a plus 2b plus 5, and therefore we'll put the 5 back up here. Negative 6 equals 4a plus 2b, like so. And then, alright, awesome. So we've got already found the value of one of the unknowns, and we've got one equation with 2 unknowns. Alright, awesome. Now looking at this derivative function here, let's see if we can build another equation. So let's go 0, and the reason it's 0 is because if this is a stationary point, then it's going to have the same x value, but the y value will be 0. That's how we know that this stationary point, or this point here, lies on this derivative function. So 0 equals 3, 2 squared plus 2 times 0 plus b. Let's take it back. That's not 0. That is 2 times 2 plus b. Actually, let's take it back a step. I'm far too ahead of myself. All right, let's go again. 3 times 2 squared plus 2a times 2 plus b. All right, that's better. 0 equals 3 times 4 plus 4 times a plus b. Therefore, negative 12, so this guy here, equals 4a plus b. All right, awesome. This will be equation 2. So what we can see is we've got two equations with two unknowns. Now to find those two unknowns, what we can use is substitution. So let's go, let's line them up, and we'll go negative 6 equals 4a plus 2b. Then we've got negative 12 equals 4a plus b. And what we're going to do is we're going to subtract the two equations from one another. So what this will work out to be is negative 6 minus negative 12, 4a minus 4a, plus 2b minus b. The two negatives becomes a positive, so it's just 6. That gets cancelled out, and then it's plus b. So in which case, therefore b equals 6. And now that we know b equals 6, let's pick our first equation. B is 6, so 4a equals 2 times 6. Therefore, this will be 4a plus 12, and therefore negative 6 minus 12 equals 4a. A equals, this will be minus 18 divided by 4. So our answer in this case is, we'll say 9 over 2. Not too bad, or we can say it's it would be 4.5 minus 4.5. So what we've been able to find is the curve blah 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 passes through stationary points. Find A, B, and C. So we were trying to do that bit there. What we find is that A, or firstly C equals 5. Then we found that B equals 6. And then we found that A equals minus 9 over 2. So what we've done is we've solved this equation using the derivative, because it told us we had a stationary point. So the tricky things, or the new things that we haven't seen yet, so the first time we've seen these, is the stationary point for this guy here relates to the 2 and 7, and the 2 and 7 becomes a 2 and 0 when we take the derivative, because the stationary point is where the derivative cuts the x-axis.